Hello, everybody out there in Math 150. Here we are today. We're going to be talking about section 3.1, which has to do with polynomials and an introduction to polynomials. Our first learning objective is to identify polynomial functions and their degree. The first thing I'm going to do is I'm going to give you the formal definition of a polynomial. It is given by this expression right here. Now, I'm not going to read this whole thing because there's just a lot going on here. Instead, what I'm going to do is I'm going to break it down from the very beginning. So to break this down, what you need to know is that there are three different letters that we're going to be dealing with. One is A, one is n, and one is x. A or a sub n, you see there's different subscripts for all these a's, but they all work the same way. All of these a's are going to be any real number, okay? So a is any real number. So you can pick any number on the number line and substitute it in for any of the a's. Now, in a lot of ways, the most important one to start with is the n value. So the n refers to the degree of this polynomial. I'm going to come back to that word in a little while, but n is going to be any number from the set of whole numbers. So n can be any number starting at 0, 1, 2, 3, 4, dot, 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 and go as high as you want. Obviously, I'm not going to list them all, but it's going to be one of these whole numbers. And then x is the independent variable. Okay, this is going to be our input. So there's no surprises with that. We've been dealing with those with functions the entire time. So as we go to write a polynomial, the first thing you're really going to be interested in is what is the n value? Now, n again is defined in this case as the highest exponent, okay? It is going to be the highest exponent of the problem. And we know it's going to be the highest exponent because according to our formula here, we start with n, and then after that, we're going to subtract 1. And then we're going to subtract 2. And then we're going to keep subtracting until eventually we get all the way down to 2, and then this is x to the first. And keep in mind that we have an a0 here. I could write an x to the 0 here. X to the 0 is equal to 1, but that's why we don't write it. We leave it out. It's easier to leave it out. So it's just going to be a0. So these are the n values. It's the powers of this polynomial. So what I'm going to do for this example is I'm just going to pick, let's do n equals 5. So if we do n equals 5, that means everywhere we see n up here, we're going to replace it with 5. And eventually it's going to work its way back to get down to the second power, the first power, then the 0 power. So what I'm going to do now is pick an a value. So let me pick an a value. So let's just write this polynomial out. And I'm picking these numbers arbitrarily. So the first a value I might pick might be 10. And then I would get x to the 5th because our n is 5. Now I need another a value for the next term. And it can be a totally different term. As long as it's a real number, we'll be okay. I'm going to use 3, and this time it's going to be x. And this time it's going to be 5 minus 1, because I'm going to that next exponent right here. So it's going to be 5 minus 1. So I'm going to get 4. The next one, I'm going to choose another real number. I'm going to choose negative. Let's say I choose negative 3/2. That's a real number. And I got to drop the exponent by 1. That's going to be x cubed. Another real number could be plus 2, and I got to drop the exponent by 1, so it's going to be squared this time. Then we're going to keep going in this order until we work our way all the way down to the last term, which has no x, or you can think of it as x to the 0, so you don't need to write it. And then I'll just write, and it can be any real number at all, so I'll put 17 there, okay? This is an example of a polynomial. They always go down by 1 in the exponent, and there's always a real number. So now just to tackle kind of the idea of these a sub n's, I chose n as 5. So what that means is a sub 5 is the number in front of x to the 5th. So in this case, it's 10, okay? A sub 4 is the number in front of x to the 4th. In this case, it's 3. A sub 3 is the number in front of x cubed. Now be careful with this one. It's not 3/2. It's actually negative 3/2. You've got to include the negative, okay? In the first two, those were positive, so it didn't really matter if we mentioned it. This one's negative, we got to include it. In this next one, a sub 2, it's positive 2. And the next one, that's going to be called a sub 1, and that's negative 7. And the last one by itself is a sub 0, and that's going to be 17. So again, each of these a sub n's are the number written in front of their corresponding exponent. So a sub 3 is written in front of the cube, a sub 4 is written in front of the 4th, a sub 1 is written in front of x to the 1st, and so on. So that's how you can identify it. If you see an expression that can be put in this form, it might not look like it at first, but if you can put it in this form by manipulating it, this is going to be a polynomial. And remember, the highest exponent, that's going to be called the degree. The degree of the polynomial is the highest exponent. This guy down here is degree 5. Okay, degree 5 polynomial. So there's an example. We're going to look at our first kind of, oh, I'm sorry, we got two more terms to define. There's the leading coefficient of the degree. We already said that the degree is the highest exponent in a polynomial. So make sure you have that down. And the leading coefficient, okay, if we call the highest degree in the polynomial, if we call that n, okay, that's what the degree is going to be, n. The leading coefficient is always the number written in front of that highest power, okay? So it's the coefficient of the term with the highest power. So we can write that as the number in front of the term, in front of the x, let's call it that, in front of the x with the highest power. If we go back and look at this last example, the leading coefficient is right here, okay? The leading coefficient is 10, and the degree is 5 in that example. So we're gonna look at a couple more examples, just making sure you can identify polynomials. So which of the following are polynomials? Okay, so you're looking to see, can you write it in that form? So right away, you look at this first one, and you see that the highest exponent is 6. So since the highest exponent is 6, you're thinking, okay, this could be a polynomial. Now, does it work its way down? So you're probably looking and saying, hey, is there an x to the 5th? Because that's what you're looking for next. And you don't see it. So now you might not be sure if this is a polynomial, but let's just play this out. There is an x to the 4th, there is an x to the 3rd, but we appear to be missing an x squared and an x to the 1st. So does a polynomial need every single term? Well, according to our definition, we are going to have all those terms dropping by 1 each time. So here is what you need to know about this one. This can be rewritten. You can rewrite that as 3x to the 6th. Now you want an x to the 5th term, but there isn't one. So how do you get around it? You use your friend 0. It's really 0x to the 5th. Now you go negative 8x to the 4th. You go plus 1/5 x cubed. You go, I need my x squared term, but there isn't one, so there's going to be 0 of those x squareds. The same thing for those x terms, and then you get that minus 7 at the end, okay? So this can be written as a polynomial. This can match the form. We can see the exponent drop by 1 every single time. I can now ask you questions like, what's a sub 4? And if I asked you a sub 4 in this one, you should look in front of the x to the 4th. A sub 4 would be negative 8. I could ask you, what's a sub 2? Now, in the original problem, there is no second power, so you could just say it's 0, or if you thought about the way we wrote it, a sub 2 is right there, it's going to be 0. Question 1, yes, this is a polynomial. We're good on question 1. It's a polynomial. So now we go to question 2, and we're asking, is this a polynomial? So again, the first thing you need to find is that degree. And let me just back up. The last one up top, the degree is 6 for number 1. So now number 2, if it's a polynomial, there should be a degree. So does it have a highest exponent? Well, the highest exponent I see in this one is that 3. So I'm going to try to rewrite this, bring that in the front. So that's going to be negative root 2 times x cubed. Now I'm going to drop it by 1, and I've got that term as negative 10x squared. I want to drop it by 1 again, and I've got a plus x. And now if I drop it by 1 again in the exponent, I'm not going to have an x, so that's just going to be plus 2. This follows the pattern of an x to the 3rd, an x to the 2nd, an x to the 1st, an x to the 0. Looking good. Are we okay? Well, are the coefficients all real numbers? Well, negative 10 is a sub 2. This is going to be actually an understood coefficient of 1 slid in there. So a sub 1 is 1. A sub 0 is 2. So the only one you might have a little bit of question about is a sub 3, which is this guy, negative root 2. But negative root 2 is a real number. We're good on this one. So in this one, the leading coefficient would be right here. It would be our root 2. That's our leading coefficient. And our degree would be the highest exponent, and that would be, this is degree 3. Number 2 is a polynomial. When we get to number 3, again, we're looking, can we find the degree first? If it has a degree, we're halfway there. And the highest exponent is 3. So we're feeling pretty good about this one. It goes from 3 to 2. There's a 1 there. But now we run into this 1 over x. And this is going to create a problem. This is going to prevent it from being a polynomial. Polynomials never have x's or variables in the denominator. If you see a variable in the denominator, no polynomial right away, okay? So this does not have a degree. This is not a polynomial. This is a different type of function. We'll be learning about this in a different unit. When we go to number 4, again, we're looking for exponents. Depending how familiar you are with your exponents, you may say to yourself, well, I can rewrite this as x to the 1/2. That is an exponent. Square root does mean 1/2 plus 12. So you're thinking it has a highest exponent, but remember, the exponents must be whole numbers. So 1/2 doesn't fit. 0, 1, 2, 3, 4, working your way up. Those are the whole numbers. This is not a whole number. The exponents must be whole numbers. This is not a polynomial either. When we get to number 5, if you remember what we said from number 3, it's going to be an effect. We've got x's in the denominator, not a polynomial. Now, what's ironic about this one is that if you look at the numerator by itself, that's a polynomial. If you look at the denominator by itself, that's a polynomial because we've got a highest degree. They work their way down in the exponent, and we only use real number coefficients. So the orange highlighted, the numerator is a polynomial by itself, the green is a polynomial by itself, but as soon as you divide them, you prevent yourself from having a polynomial. So there's no polynomial here because we've got x's in the denominator. So no polynomial on this one. Now on the last one, it's kind of interesting because we've got a bunch of factors, and so far polynomials have needed to be terms. But here's the thing on this one. What you have to recognize is if you started multiplying this all out, not that we're going to, because this is a lot of multiplication, but let's just do the first two. Let's just talk about multiplying out the first two so you can see what's going to happen. I would get x squared, I'd get 3x, I'd get negative 4x, and I would get negative 12. That's going to give me x squared minus x minus 12. But now I could continue and multiply that by the next one. And if I were to do that, I would be adding terms as I go. And each time, because I'm doing that first multiplication, I'm going to go up another power. My answer for the first 3 factors is going to have an x cubed. My answer when I include the first 4 factors is going to have an x to the 4th. By the time we get to the 5th factor, that'll be an x to the 5th. And once we multiply out this whole thing, we're actually going to end up with an x to the 6th with a bunch of terms with the exponents going down by 1 each time. This will be a polynomial, but we would have to multiply it out to predict some of its properties. One thing you can predict, though, is because all these x's are just 1x, that's how I'm going to get the x to the 6th, the highest power. So we know if we just multiply let me erase so you can see what I'm doing here. If I just multiplied that x times that x, that's going to get me the x squared. Then if I continue to multiply by that x, I'm going to get the cubed, the 4th, the 5th, and the 6th. So I can predict that the degree of this one is 6, and I can predict the leading coefficient will be this one times this one. There are ones being multiplied every time. So I even know that a sub 6, which in this case would be the leading coefficient, would be 1, okay? This guy is a polynomial. He just is all factored out. Once you expand all this, we would have a polynomial. So that's going to end our first section, our first learning objective today, just identifying polynomials. Make sure you understand degree, make sure you understand how that polynomial formula works, and make sure you can find the leading coefficient. Hope that makes sense. I'll be coming back soon with another video for the next part of section 3.1.